The one rule of establishing very smooth curvature when using subdivisions is to try and keep your geometry to an absolute minimum. When you're in the initial stages of building a shape, you want to try and keep things really simple, as this will allow you to create very smooth curves. Now, to give you an example of this, I have this spline here. It's a B-spline, it's divvied up into 3 sections, and I'm just going to recreate this in geometry. I'm going to grab my pen tool, deselect our spline. Now, I'm going to do this with 3 polygons. Try and keep it to the same topology as our spline. So just drawing out 3 polygons here. So let's throw this into a subdivision. Now you can see we have a few problems here. First off, I'm just going to weight these points so we get some kind of sharp corners. So the points I created on either end are pretty much in the same position, but you can see my curvature is quite a ways out from this spline. Now the reason for this is because I created the points of my control cage actually on the spline, and if we look at the spline here, we can see that the control points for this B-spline are situated way up here. Now with subdivisions we have to use the kind of same principle of overshooting our curve. So I'm pretty much going to want to place these 2 points here in the same kind of ballpark as my B-spline curves, overshooting the curve I'm trying to make. And you can see that once I do this, our curvature matches up pretty good. And if we select both these objects, you can see that this point is relatively close to our B-spline point. Over here it's a little bit different, but height-wise it's actually the same distance away from this point. And the reason they don't match up is because of the sort of curvature interpolation differences between the spline and the subdivision. So you can see that I can create very smooth curves like this with very little geometry. Now there's nothing to say that I have to keep things this low poly. I can create this curvature very easily. Let's grab the pen tool in polygon mode, and if I draw out a strip of polygons, and this time I'm going to try and keep pretty close to the spline, and if I subdivide this, you can see that because there's more resolution in our base mesh, that I don't need to overshoot this so much. The problem with this amount of geometry is if I want to make changes to it, I have to deal with more points, and there's more that can go wrong with the curvature having this many points. And this is because the surface tension in the subdivision is now greater, and it will now be a little bit more susceptible to bumps. If you're having to deal with really wide sweeping curves, manipulating a lot of points becomes a lot more complicated. You're also going to have to deal with more geometry in your mesh if you start with this kind of resolution. Whereas if you start quite low poly, it's a lot easier to fill in holes and gaps and resolve to quads because you don't have to deal with such a high poly count. Now, one situation where this kind of thing will change is when you have varying degrees of curvature. So a good example of this varying degree of curvature would be our spline shape that we saw in the first video. And you can see we have these very broad curves around this area. And as we get into here, we have this rather acute kind of curve. So the general rule here will be that we could try and build this in a very low poly manner around here, and then we're going to need some more geometry in this area to accomplish this curve when we subdivide. So what I'm going to do is I'm going to create the topology very quickly for this shape. And we'll also have a look at how we can ensure we have a continuous edge loop so we get really nice smoothing on all of our edges using the concept of edge flow to achieve this. Now it's not going to start out like this, but I'll show you how you can resolve your edge flow at a kind of later stage in the modelling process. So I'm going to go into point mode, and I'm going to start here and draw a quad here. Hold Command, copy out another quad by dragging that edge. So now I have two quads here, and what's going to happen is this quad is going to be sort of copied out around this shape and then eventually rejoin with this edge. So let's do that. Now I'm trying to make this as kind of simple as possible. You can see the polygons are quite large, and I'm kind of overshooting these points, as I know that this will eventually shrink down once we subdivide it. Now this will probably be kind of a different set of topology than the shape from the first video, as you can pretty much do this a few different ways. So when I get to here, what I'm going to do is draw this point in so that I can essentially bring this polygon around the corner. So you can see I've moved this point down to here, and that's so I know that this is going to curve up properly. And then I'm going to bring polygon here, and this is my sharp corner. Now when you're making shapes like this, you have to think about the fact that you have to fill this hole in, and we'd quite like to fill this hole in with some quads. Now I haven't been paying attention to my edge count, so I don't know if this is actually going to work yet, and I might have to end up cutting some more edges in, but we'll see how we get on. Now if I just copy another edge to here, now I can weld this point here. Now I also want my quads to be fairly evenly sized as well. Now I could fill this hole by doing this, or I could also fill this hole by doing this. And then maybe what I could do is bridge over to here. But you can see this leaves me with a bit of a predicament that I have quite a few edges on the bottom here and only one edge here. So this may not be the best solution. Let's go back a few steps and let's try this. What I think I'm going to do is do this. And then bridge this over. Okay, so that's a fairly kind of decent result. Let's bring these points out. I try to make everything a little bit more evenly spaced. Again, this is just one scenario. Had I drawn this out with perhaps another edge going around this, this inner topology would probably be different just due to the amount of edges that we have. So now we need to see if our curvature is actually working. So let's get a subdivision and subdivide, and you can see we're pretty close here. Just need to tweak a few points. And kind of the more you do this, the easier it is to gauge curvature, even if it isn't subdivided. So I'm going to have to move this point out here. But all in all, we've managed to accomplish this. And the results are pretty much exactly the same as our spline. Now, what I currently don't have is a continuous edge loop around this shape. I'm pretty much 95% of the way there. But at the moment, this edge loop that's running around this shape is starting on this edge here and travelling through these opposite edges. It's coming round here and then terminating at this edge here. Now, to get this to run in a continuous loop around my shape, I'm actually going to subdivide this surface, as currently I don't have enough geometry to accomplish this task, but it should be pretty easy once we've added another iteration of subdivision to this. And this is a fairly common technique when you're modelling, is you build the shape in a very low poly way and then subdivide it by one iteration, which gives you more geometry to play with. So I could subdivide this by, giving this one iteration with my subdivision surface and hitting C to convert that to geometry. Or I can grab my polygon, go to Mesh, Commands, and say Subdivide, and make sure I have Smooth Subdivision checked. So I'll show you what the results are of both of those. Let's subdivide. I get this mesh. Turn off the subdivision. Go to Command, Subdivide, Smooth Subdivision, and I get exactly the same result. Now you can see the result of the subdivision is that we have a fairly even mesh, which is obviously going to deform really well as the surface sort of tessellation is pretty even. So currently in this geometry, what we have is an edge loop that is running around like this. And we want to make this continuous. We can see we have these kind of corner quads here. Now, if we want the edge flow to run around here, all we have to do is do what we did in the first edge loop video and just weld to our corner point. And now you can see we have a continuous edge loop. So I'm going to want to turn back on my subdivision and just move some of these points around just to re-establish kind of my curvature. Let's kind of even some of these out. So to turn this into a solid object, we just need to grab all our polygons, extrude. Let's extrude this out. I'm going to give myself a few more subdivisions down here. So ring selection, edge mode, knife cut tool, hit apply. Now when we subdivide, let's give ourselves a couple more iterations. You can see that we have this shape just made up of, plain old geometry. So this fuel tank would be a very good example of an object that would benefit from this very low poly approach to curvature. This is obviously a very smooth curved surface, and to establish this we would really want to keep our geometry to a minimum. Now we also have this indented feature here, so the edge flow around this detail is probably the most important thing we have to consider in this object. And we also have another set of curvature actually in this indent where it's very rounded inside. Now edge flow is a big part of curvature in subdivisions, so I'm going to want to maintain a really smooth edge flow between these two surfaces. So I'm just going to model this for you quickly so you can see what I mean. So I'm going to start here in my front viewport. Now probably the easiest way to make this is to just create a plane and scale my dimensions . and give this 8 segments. So I really do want to keep this low poly. Now the first thing I'm actually going to model is the indent shape. So I'm going to make this editable. What I'm actually going to do is I'm going to put this into symmetry, because that way I know I will get a good result. Let's bung this into symmetry on the XZ. Then I have to work with even fewer points. So let's start by making this kind of oval shape at the back end. Increasing kind of size. If I move to my move tool, I can use tweak mode to very quickly get this shape. And then here at the front, make this curvature here. So you can see very, very low poly. Now I'm going to break that down by hitting C into just regular geometry. Now, when I think about curvature like this with these kind of corner polygons, I'm very much thinking of this in terms of a disc or half a disc. And the same with this on the other end, except we've obviously elongated these points out to create this oval shape. Now, because I need to create some curvature in here, I'm going to need some more geometry. And what I'm going to do is grab all of this in polygon mode, and I'm going to inner extrude it. Now, this gives me the edge flow I need around the outside. Obviously, you can see I have a loop running round this geometry now, which is good. I'm just going to move some of these points, tidy this up, and all I need to do to create the curvature in here is move these inner polygons backwards. We'll do that a little bit later on. So to create the actual tank, all I have to do now is grab these edges, or this edge loop around the outside, and I'm just going to extrude out. Now my first extrusion is going to be quite large. I'm going to grab these points, try and carry this kind of oval shape to the back. Command Control to deselect this point, and then just scale that down like so. Back to edge mode, and then we're going to make one more extrusion. Now, just a quick tip here. You might have noticed that I made my second extrusion there slightly smaller than my first one. And this is because when you look at a curve like we have here in the front viewport, you can see that this is how the topology looks, with this surface appearing larger than this surface, even though they're actually both the same size. Now, when you're working out flat topology, it's a good idea to actually think in this kind of viewport when you're trying to get this kind of result. And it makes extruding back your geometry to create curves a lot easier. What you would do is take your first edge and drag this kind of back like so, and then move your second edge back, extrude out, and what you end up with is a pretty good curve. Now, you'll probably see me do this later, and it is an incredibly useful way to think about flat topology when the end result is going to be a curve. And you can map your flat topology out to get many varying degrees of curvature across these transitional edges of your geometry. So just a quick tip there. Again, grabbing these endpoints, kind of moving them back, deselecting and scaling. And just making a few minor tweaks there. So that's the kind of shape I'm going to go with. Now, to create the curvature here is very easy indeed, because all we have to deal with is two edges. Now what I'm going to do is I'm going to move this edge back like so. So I get this. And then I can select this inner loop here and just kind of move this backwards as well. And this starts to create this nice curve. And then what I'm going to do is grab this edge and kind of extrude this in to create the main body of the tank. Now I can easily just affect this curvature by bringing these edges backwards or forwards. And you can see it's a very easy process with a very minimal amount of geometry. We've managed to get this shape to work. Now I can subdivide this. And we can see the kind of effect that we've got, and this is pretty good. So I'm going to put this whole thing into symmetry now. If I go to object mode, you can kind of see here that my axis point is in the wrong place. I need this to be at the center of the object for the symmetry to work properly. So I'm going to grab my axis center tool. I'm on the Z axis here, so let's try minus 100 or plus 100, which puts our axis point in the right position. Reset and close. And now we can change the coordinates of our object to world 0 on Z and apply a symmetry object on the XY, and that's pretty good. Now you can see this looks slightly square here, and I'd quite like this to be a little bit more curved around the top. So again, that's probably going to be pretty easy to do. And grab this center edge, and let's just scale that up slightly, which gives us a kind of a nice curve at the top, and that is a pretty simple modification, but it's had quite a radical effect. So I'm happy with that. Now then, let's take care of this indentation here. Poly mode. Let's move these polygons back. Our subdivision. Then all I need to do to create this kind of curvature is move these two edges back in the middle. And that should work out pretty nicely. Now I don't think we're going to see the full extent of this curvature until we sharpen this edge. Now before I do that, we need to think about something else here, and there will be a fuel filler cap here. Now currently we don't have enough geometry to make this. We need to make a circle here. If I were to bevel this point to create a hole, because there kind of isn't enough geometry here, if I cut these end-on lines out, we're going to get distortions. We need to increase the resolution of this mesh for this hole to work properly. We need to create more geometry to establish the shape better. at the moment this shape is quite fragile because it's so low poly. Now we would do that by effectively breaking down our subdivision to something like this. That would give us this nice area here that we could put the filler cap in. It won't have such a devastating effect on the surrounding geometry. Now, before I do this, I have to consider one thing. Firstly, if I want to bake this down to geometry, my subdivision render amount is basically the setting for baking this down. If I were to hit C now, you can see this would be rendered to geometry with 3 subdivisions. Whereas if I set this to 1 and hit C, I get the same result I'm seeing in the editor. And also I want to sharpen this edge feature. And I don't really want to cut into this mesh because, you know, if I were to bevel this edge, I'm going to get an increased amount of geometry in this area when I bake down. So the best thing for me to do is actually to weight this edge. So I just double click. Everything in this mesh is so easy to manipulate because it's all edge loops and simple geometry. So if I just hit the period key and swipe to the right, this has actually weighted this edge. Now we can see our weighting here, and if we subdivide, we haven't really got much of a radical effect here, and this is simply because of our Fong tag. If I lower that down a little bit, we can obviously see the effect of this weighting. So that's with. I just delete that without. And this should set us up really nicely for baking this object down. Now, one more thing I may want to do is just tweak the overall shape of this object. Now, because it's so low poly, this is probably pretty easy to do with just points. May want to see I'm having a bit of a difficulty striking a balance between these Fong settings, so maybe I just don't even want to bother with that for now, as I would sharpen this detail once it's baked down. I can easily manipulate these points to, you know, change certain aspects of this shape. Probably the best way to do this, though, would be to add an FFD deformer. Let's give this some more segments on the Y. Now we could maybe a couple less on the Z. You know, kind of grab these points and just change kind of the overall shape of our object very easily. Don't underestimate the FFD. It is so useful for manipulating meshes, especially once you've got to a point where you have quite a lot of geometry and that moving individual points around isn't an option. This is a fantastic tool for deforming meshes. You can make some really interesting kind of sweeping changes to your model. So I'm going to go with that. And then to finish this off, what I would literally do is grab this whole lot, hit C, and turn this into geometry. I now have enough geometry up here that I can make my filler cap, which will be done very easily by beveling out this point, or this point, depending on where I want it. Get rid of the end-on lines. Create a hole there. I want to make this even smoother. Subdivide again. And you can actually see that by adding this extra geometry into our actual mesh, that this doesn't actually really need a lot of sharpening. The actual process of just bouncing that down has actually done that for us. Saying that though, we could easily solid chamfer a tighter curve into this. Like so. It's a pretty good result. Let's go to our move tool, modeling axis. Let's put this in the normal direction, the average normal direction of these edges. Scale to 0. There we have the start of the fuel cap. So dealing with very sweeping curvature, we've managed to end up with something that vaguely resembles our image, but the main thing is that all our curves are very smooth. And obviously this was facilitated by building the initial base mesh, very low res, and then up resing as we go on. So with the thought in mind that this concept of edge flow promoting curvature, what happens when we interrupt the edge flow?